Hey, how's it going? Mr. Dent here. Today's topic is resolving vectors. Today, here's what I'd like you to learn. I'd like you to know how to resolve vectors into their horizontal and vertical components. So what exactly do I mean by that? Well, first let's just talk about vectors and how we can actually describe them by their set of perpendicular components. So any vector has an x component and it has a y component. And so here I have a vector drawn, the blue line with the arrow. And, and so this would be similar to earlier sections where we talked about adding perpendicular vectors. This is sort of doing the opposite. We're seeing what components add up to give us that vector. So the x component is the horizontal component, and the y component is the vertical component. And so the x component, please don't think it has to be on the x-axis. It just simply means it's parallel with the x-axis. And then we could say the same thing for the y component. It just means it's a component that is going to be parallel with the y-axis. Okay, so let's use this same triangle to talk about how we would resolve a vector. So resolving a vector is simply the process of breaking a vector down into those two components that we just talked about. So as long as we know the magnitude of the vector and we know the direction of the vector, then we should be able to do this. So here we have a vector that has a magnitude of 92 kilometers per hour, so this would be a velocity vector, and it has a direction of 36 degrees north of east. And so to do this, we're going to have to use some functions that we would typically use to solve triangles or in trigonometry. So the two functions that I'm talking about are the sine function and the cosine function. So by definition, sine of an angle is equal to the length of the opposite leg divided by the length of the hypotenuse. And the definition for the cosine of an angle is going to be the length of the adjacent leg divided by the hypotenuse. So the angle, which is shown here, 36 degrees, so the side opposite is the y component. So to find the y component, we're going to use the sine of the angle being equal to opposite over the hypotenuse. So in this case, the hypotenuse is 92 kilometers per hour. Now, you should just go ahead and rearrange your, this equation or this relationship we have here. So opposite is going to be equal to the sine of the angle, which is 36, multiplied by the hypotenuse. In this case, it's 92 kilometers per hour. And so that gives us opposite equal to 54 kilometers per hour. So the y component is 54 kilometers per hour. We can do a similar thing with the x component. Since the x component in this case is adjacent or next to the angle, then we would use cosine. So again, cosine is equal to adjacent over hypotenuse. So again, our vector is the hypotenuse, and we know the angle, so we can plug these numbers in. So cosine of 36 is equal to adjacent over 92 kilometers per hour. We could rearrange and solve for adjacent. So adjacent is going to be equal to cosine of 36 multiplied by 92 kilometers per hour, which gives us 74 kilometers per hour. So the x component is going to be 74 kilometers per hour. Okay, so let's use this process to solve a real problem. So here I have a truck and it has a camera in the back, and so this would be like on a movie set where the airplane is flying along and we have to film this airplane flying along from the truck, but we need the truck to go to keep up with the airplane. And so in this case, the airplane is flying 105 kilometers per hour at an angle of 25 degrees to the ground. And so we need to know how fast the truck needs to be traveling to stay even or keep up with the airplane. And so essentially we need to find this horizontal component of this vector of 105 kilometers per hour. And to do this, since this is the side, and we know that this angle is 25 degrees, so this side is the side adjacent, so we're going to use cosine. And so we just simply do as we did before. Cosine of the angle is equal to adjacent over the hypotenuse. Rearrange and solve. So cosine of 25 degrees multiplied by 105 kilometers per hour gives us 95.2 kilometers per hour. That would be the x component of this vector, of our original vector. Now, since the question didn't ask us for the vertical component, we won't go ahead and solve for that. Now, one thing before I end today, I wanted to talk about what if we have vectors that are parallel with our main axis. So like the yellow line here is parallel with the y-axis. And so, you might think, well, it doesn't have two components, and that is true. However, I just want you to understand that, let's say this was 5 meters. That's what this represents, a displacement of 5 meters. So the y component would be the 5 meters, and then the x component would be 0, since there is no angle here, so there is no side to side or horizontal movement. The same thing can be said for this. So let's say this is 4 meters. The x component would be 4 meters, and the y component would be 0. I know that probably is fairly obvious, but I wanted to make sure I pointed that out in case we run into those kinds of situations, and I don't want us to be confused by those. Okay, this pretty much concludes this screencast.